So now we're going to get down and actually calculate these variances. So again, I hope you've got your notes printed with you. I hope you have a calculator handy so that you can really engage with the content and write it all out and get your notes out so that when you can practice before you get to the homework in my accounting lab. So we're just going to zoom in real quick on that flexible budget variance, and we're really going to focus on this difference between the actual and the flexible budget results for materials and labor. This is what I'm looking at right here. I'm going to examine this 13,000 unfavorable for materials, break it into its cost and efficiency components, look at the labor, the 10,400 favorable, and break it into its cost and efficiency components. So we know that the flexible budget variance for direct materials is 13,000 unfavorable. Essentially, we know the ending answer before we even start the problem. Some additional data that we are given is we are told that the direct materials cost standard is 35 cents per pound of paraffin. Remember, we're making crayons here, and I always thought crayons were made out of wax, but apparently they're made out of paraffin. So 35 cents per pound of paraffin. Our standard quantity of materials used is 5 pounds of paraffin per batch. Now, the actual amount of paraffin that we purchased and used last year was 325,000 pounds, and we actually spent $104,000 on this. And remember, we already know this, but just to keep in mind, we made 52,000 batches. So let's go to the next slide, and we're going to work through this. This is the way I like to work the problems. So the first thing I do is there's 5 things that I want to list out. I want to know the standard price, the standard quantity, the actual price, the actual quantity, and then what I call N, which is how many units that we produce. So I find, because these are word problems and word problems can be tricky, that I find it best to write it out in a list as I go through. So we were given the data already. I'm going to write it out. So my actual quantity was 325,000 pounds. Now, I want to encourage you, don't forget to write the pounds or abbreviate LBS or something. If you just put 325, you're going to confuse yourself later on. Now, the actual price that I paid for those was $104,000. Now, my standard quantity was 5 pounds per batch, and my standard price was 35 cents per pound, and what I call N, which is our number of units that we made, was 52,000 batches. Now I realize that you may be thinking I just wrote down everything you gave me in the problem, but I promise we're going to do something with this in a minute. Now, it turns out that as I'm comparing this data, let's just look at our quantities. I'm comparing 5 pounds per batch with 325,000 pounds. And I'm trying to see, did I use more materials than I had planned on? Well, I can't compare 5 pounds per batch with 325,000 pounds. One's in total, one's per batch. If I look at the price, I've got $104,000 and I've got 35 cents per pound. I'm trying to see, did I pay more than I had planned on, but I can't compare it like this because, again, one is in total and one is per pound. So I need to convert some of this data to make it where I can compare it. So there's different ways that you can convert it, but my advice, my strong advice, is that you want your quantities in total. So I call it QT. We want quantities in total, and we want prices per. Now this is not price per batch, this is price per unit of measurement for my materials. So let's just start with the quantities. So my actual quantity is 325,000 pounds. My standard quantity is 5 pounds per batch. So if I want both quantities to be in total, I need to convert the 5 pounds per batch to the total. So if I'm making 52,000 batches, the total quantity of materials that I would expect, I would say 5 pounds times 52,000 batches equals 260,000 pounds. So I thought I should have used 260,000 pounds of materials. I actually used 325,000 pounds of materials. I can already tell right now that the efficiency is unfavorable. I don't know how unfavorable it is yet, but it's unfavorable. I used way more pounds of materials than I had planned on. So I'm going to just write myself a note down here. The efficiency variance is unfavorable. Again, I don't know how unfavorable, but I do know that it's unfavorable. Now, if I look at my prices, my actual price was $104,000. My standard price is 35 cents per pound. So since the standard price is already in a per pound basis, I want to convert the actual price and make it per pound. Now, let me caution you. The common thing is to divide $104,000 by 52 batches. That would give you a price per batch, but then that would have you comparing a price per batch with a price per pound, and we don't want to do that. We want to compare price per pound with price per pound. So this $104,000 was used to buy 325,000 pounds of materials. So I want to divide this by 325,000 pounds. And when I do, I get a rate of 32 cents per pound. So I thought I was going to pay 35 cents a pound. I actually paid 32 cents a pound. I paid less than I had budgeted for. This is a good thing. So this tells me that my cost variance is going to be favorable. I don't know how favorable it is yet, but I do know that it is favorable. Now, let me say one thing is you will not always divide the actual price by the actual quantity and multiply the standard price by N. It depends on how the data is presented to you. In some cases, the data will be presented to you like this. In some cases, it won't be. So you'll have to look at the data and do whatever you need to do to get your quantities in total and your prices per. So So this is just reviewing the data that we just looked at where we've already converted it all to us and reminding us that we want quantities in total and prices per. So now we're going to go to our chart. So now I'm going to go to my chart. And this is the chart that we had drawn up here. And we're really just going to plug our data in. So I always say we're going to plug and chug. So when I look at, you've got your data in front of you. Remember my actual cost was 32 cents per pound. And my actual quantity was 325,000 pounds. So when I multiply that out, that comes out to the 104. Now my standard cost was 35 cents per pound, and I multiply that by my actual quantity of 325,000, and I get 113,750. And then my standard cost is 35 cents, and my standard quantity I calculated to be 260,000 pounds, which is 91,000. So now to get the variance, I'm just going to take the difference. Now let me explain something. The difference is always positive. Variances are always positive. If you enter a negative variance, it will be wrong 100% of the time. So regardless of how you plug it into your calculator and how it comes out, you enter that variance as a positive number. Variances are always positive. A variance is just the difference. So 104 minus 113,750 will come out as a negative number on your calculator, but you don't write it as a negative number. So when I plug it in, I get a negative 9750, but I'm going to answer it down here as a positive 9750. And then we can identify whether this variance is good or bad by looking at our data. So remember, we said we thought we were going to pay 35 cents a pound. We actually paid 32. That's good. So this is a favorable variance. So even though it came out negative on your calculator, this is a favorable variance. This means that by buying cheaper materials, by saving 3 cents per pound, it saved the company $9,750. Now, when I look at the efficiency variance, this is again going to be the 113,750 minus the 91,000. This comes out as a positive number on my calculator of 22,750. But I'm not going to just assume because it's positive it's favorable. I'm going to look at my data. So I thought I was going to use 260,000 pounds of materials. I actually used 325,000 pounds. That was very, very, very bad. So this is definitely an unfavorable variance. So even though it came out as a positive number, it is an unfavorable variance. So this tells us because I used so many additional pounds, what is that? 65,000 pounds? That 65,000 pounds cost me $22,750. So my total variance then is going to be the combination of the cost and the efficiency. Since one is favorable and one is unfavorable, I'm going to subtract them, take the difference, and use the sign, so to speak, of the largest one. So I'll say 22,750 minus 9,750 gives me 13,000. And since my unfavorable variance is the largest, then the total variance is unfavorable. So if you have two variances that are different, favorable and unfavorable, you subtract and use the sign of the larger one, just like we did in math. Now, if it happens that you have two favorable variances or two unfavorable variances, then you add them and they'll be favorable or unfavorable. Okay, so we already knew that this answer was going to be 13,000 unfavorable. We just didn't know how we got that. So now we know. We know that we saved almost $10,000 by buying some cheaper materials, but we spent almost $23,000 because we used too many materials. So if I'm looking at this, I want to know what happened. And there's a lot of different scenarios that could have happened here. And so I want to go have a discussion with probably the production manager, the purchasing manager, and say, hey, can you fill me in on what happened here? There's several different scenarios. We don't know what happened exactly here, but let's talk through some what ifs. So one what if is we go to the production manager and we're like, hey, you used 65,000 pounds more of paraffin than you should have. What happened? And they might have said, oh my gosh, there was this. There was this disaster, there was this accident, and there was a big spill of paraffin, and we had a big waste. We wasted a lot of paraffin. It was just an accident. It was a spill. And we're like, oh man, okay, that sucks. Yeah, that's bad. I remember that happening now. Okay, yeah, not really your fault. That's just, that sucks. Okay. That could have been one thing. Or it could have been that the production manager says, you know what? The purchasing manager started buying this new paraffin, and it doesn't set right. We'd put it in the molds, we would leave it for the set amount of time, and it wouldn't set. And so we wasted a lot of paraffin having to go back and remake these crayons because they weren't set. And it's just, this paraffin is not really good quality, and it cost us a lot of extra rework time. So then I'd have to go to the purchasing manager and say, all right, look, I realized that you were trying to save us money, and you saved us almost $10,000, but it ended up costing us $23,000 because your cheaper products were of a lower quality. And this is something that we see happen very often. A lot of times we try to save money by buying a cheaper product, but it turns out that a cheaper product oftentimes, not always, but oftentimes is lower quality. And so we end up using more of it, and it ends up costing us more money in the long run. I always use the example of paper towels in the restroom. If you go into a public restroom and you wash your hands, if they have those really cheap, flimsy, thin paper towels, what do? I end up taking a whole bunch of paper towels because they don't hold up. But if you go in there and they have the nice thick paper towels, then I just take a little bit of paper towels. So I always want to say to these companies that buy the really cheap paper towels, are you really saving money on this? You think you're saving $10,000, but are you really? Because people are using 5 times as many paper towels as they would if you would just buy the high quality paper towels. Sometimes it really is cheaper to spend more money and buy a higher quality product. Okay. So again, here's our summary of our variances, and they look like what we got. So now let's look at the labor variances. So we already know that the labor variance was 10,400 favorable. Some more data that we know is that the direct labor cost standard is $12 per hour. The direct labor efficiency, so we said it should take 0.25 of an hour, or 15 minutes really, to produce a batch of crayons, to 15 minutes of hands-on time. The actual direct labor hours were 10,400, and the actual cost of direct labor was 145,600. So let's go write down our 5 pieces of data, and then we can analyze it. So first of all, we need our actual quantity, which we were told was 10,400 direct labor hours. Our actual price of 145,600, or actual cost. You may choose to use cost here instead of price. I don't want to confuse anybody. I tend to call it price, but you could call it cost. The standard quantity of 25 cents of 20.25 direct labor hours per batch, pardon me, and my standard price of $12 per hour. And then don't forget that N is 52,000 batches. We already knew that. So again, don't forget that we want quantities in total and prices per. So if I start with my quantities, my actual quantity is already in total at 10,400 labor hours, but my standard quantity is per batch. So I want to convert this by multiplying it by 52,000 batches. And so this tells me that, hey, I should have used, or I would have expected to use 13,000 direct labor hours. I actually used 10,400. So my employees worked faster than I expected them to. This tells me that my efficiency variance is going to be favorable. I don't know how favorable yet, but I know it's going to be favorable. So now if I look at my prices, I want those per, in this case that would be per hour. My standard price is already $12 per hour, but my actual price is in total. So I want to divide this to make it per hour also. So in this case, I want to divide it by 10,400 direct labor hours, which gives me $14 per hour. So if I look at this now, I thought I was going to pay my employees $12 an hour. I actually paid them $14 an hour. So I paid them more than I planned on. Now, from an employee perspective, you're happy you got paid more. But from the company perspective, this is bad. We don't want to pay our employees more than we have to, right? So the cost variance here is going to be unfavorable because I paid the employees more than I planned on. I don't know how unfavorable yet. I just know it's unfavorable. So now that we have our data here, let's plug it into our chart and get to work. All right, so looking at my chart here, I know that my actual cost was 14 and my actual quantity was 10,400, which gives me 145,600. My standard cost was $12 per hour and my actual quantity was again 10,400 hours. So when I multiply that out, I get 124,800. And my standard cost is $12 multiplied by my standard quantity of 13,000. And when I multiply that out, I get 156. So again, to calculate my variance, I'm just going to take the difference. So 145,600 minus 124,800 gives me 20,800. Now we've already said that this variance is unfavorable. It's unfavorable because I thought I was going to pay my employees $12 an hour. I actually paid them $14 an hour. So I spent almost an additional $21,000, almost $21,000, because I gave them a $2 an hour pay raise. But when I look at my efficiency standard, I'm going to take the 124,800 minus the 156, and even though that comes out as a negative number, I'm going to write it as a positive. And we said that we expected our employees to take $13,000, 13,000 hours to make 52,000 batches of crayons. They actually only took 10,400 hours. So this means this is a favorable variance. So my employees worked faster And by working faster, they saved us $31,200. So my total variance, again, because I have one favorable and one unfavorable, I'm going to subtract. So that gives me 10,400, and I take the sign, so to speak, of the largest one. So since my favorable variance was the highest one, I'll say this is favorable. So again, there's a couple of different scenarios that could explain this. Let's talk through a few of them. One of them could be that we gave our employees a pay raise. And what research shows us is that when we give our employees a pay raise, our employees are happier. And happy employees are more efficient. They work faster. So by giving them a pay raise, we thought we were spending $21,000 almost, but it ended up saving us $31,000. So giving our employees a pay raise, again, typically makes them happier. If you're happier, you're more efficient. You work faster, you do better work. There's less downtime. By spending more money, save the company money. Now, research has shown that that effect is true, but that effect is short-lived. Because I don't know about you, but when I get a pay raise, I get real excited, but then I very, very quickly adjust my spending to my new income level, and I find that pretty quickly I'm back to the same things that annoyed me before. And so I don't maintain that level of efficiency very long. Now, there's a couple of other things that could explain this scenario as well. It could be that we hired new workers. We hired workers that were more experienced and or had more education. Typically, the more experience and the more education you have, the higher rate you demand. So employees who are more experienced and have more education, I have to pay them more, but they're better, more efficient workers than newbies who don't have experience and who maybe don't have the same level of education. So hiring those more experienced workers, again, is going to cost us more money, but it's going to save us money in the long run. Now, there's a third potential scenario here that I want to point out. This rate, this $12 an hour and $14 an hour, isn't just the hourly wage that you pay the employees. It's everything that the employee cost, everything that you pay on the employee's behalf. So think back to financial accounting. When we were debiting payroll expense and salaries and wages expense, it wasn't just for the hourly wage. It was also for any fringe benefits that we paid on the employee's behalf. So for example, if I were to offer health insurance to my employees, this would raise their average annual rate, even though they're not really getting a pay raise, they're getting insurance paid. So it raises the salary cost to me. But let me ask this question, because I've lived without insurance. I have insurance now, but I have lived a portion of my life where I didn't have insurance. When I did not have insurance and I got sick, I can go to the doctor. I just, took some NyQuil. That'll kill it, whatever, right? I wasn't going to that doctor unless I was on my deathbed, okay? Really, really, really sick. I also, at that period of time when I didn't have insurance, wasn't making a whole lot of money. I also couldn't afford to take off work if I got sick. So even if I was sick, I was going to have to go into work. I was going to have to work while I was there, work sick. And I don't know if you've ever gone to work sick, but you're not terribly efficient. You're not terribly productive while you're at work sick. But I had to go because I had to get that money because I didn't have a lot of money, right? But the thing is, when you don't go to the doctor when you're sick, then you're sick for a long time, right? You're sick for 2 weeks. That cold lingers for 3 weeks, for 4 weeks. Usually when I'm teaching this in class, there's half the class that is hawking up a lung. And it's that same kind of thing. They're all nodding like, yep, hadn't gone to the doctor, don't plan on going to the doctor, can't afford to go to the doctor. But if you have health insurance, now the game changes. Now when you get sick, you do go to the doctor, and the doctor says, oh, yep, this is a sinus infection. Let me give you a prescription for a Z-Pak. You fill that, you take it. Maybe you take a day off of work, and then you're back at work, you're better in a couple of days, and you're much more efficient, you're much more productive. And it's amazing how that happens. So, a lot of employers are fearful of offering their employees health insurance. They think they can't afford health insurance. It's going to cost almost $21,000. But what they don't realize is that healthy employees or happy employees or more productive employees or more efficient employees, they're going to actually save the company money in the long run. So again, here's our summary of our direct labor variances. So real quickly, before we end, we just have a couple of slides left. I want to discuss the relationship and responsibility. So we've already talked about this a little bit, but we want to investigate all variances that are significant. And this is what's called management by exception. So kind of human nature is to look down that performance report and say, oh, every budget that's unfavorable, I want an explanation of. But we tend to want to ignore the favorable variances. Oh, labor was 10,400 under budget. Yay for you. But we don't actually spend the time investigating those. So management by exception says that we want to focus on all variances that are significant. We expect some variance. We expect there to be a little bit of variance. So if you look back at that budget report that we looked at the very beginning, we saw that the manufacturing fixed cost had a variance of $1,000. To a large company, $1,000 is nothing. We see that supplies has a variance of $300. Okay, great. I'm probably not going to spend time investigating a $300 variance. That's probably a pretty insignificant variance. But I want to investigate all of the variances that are significant, whether I identify that as, anything over $3,000 is significant, or whether it's a percentage, anything over 3% is significant. And so we've talked about this a little bit. If I'm investigating the direct materials cost, I probably want to start with the purchasing manager, but we know that these can be interrelated. So the purchasing manager and the production manager. If I'm looking at the direct labor cost, I want to start maybe with human resources, but also production. So as we get into chapter 9, we'll talk more about this performance evaluations. We're going to continue on this theme, but I hope that this gives you something to stop and think about. And so one of the things I want to encourage you is, as you're working through your homework problems in my accounting lab, as you're calculating these variances, stop and think up, what are some possible scenarios that could have caused this variance to occur?